Welcome to a cold, grey, raining week in Warragul, Gippsland. But let's step back into the factory and have a bit of a look at some of the projects we've got going on.
Have a look there, we're not going to make it, we're going to hit this clamp. So that's a broken cutter, just smashed it. Start again. So I've cut...
Makino CNC mill has a job today. We've got a crankshaft set up in here that it's going to get an unusual shaped keyway cut into it. So I thought we might check in before he starts cutting anything and see where we're up to. So Brad, where are we at?
Yeah, hi Judes. This crankshaft has come in. I'll lift that indicator up and show you what's going on. This area here had been damaged, so it went out for cold welding, which is a welding process where they don't apply any heat. Then it's been ground back to its original size, which is that surface area there. And you can see here there's two keyways. They've been filled with the weld. So what we've got to do now is machine those keyways out. So to do that, we have to put this key, let's put it here. We have to put this key into the shaft. This is a curved key, it's called a Woodruff key. Got a special cutter that will cut that radius into the shaft. It's a cutter I made up ages ago that we ground up for another job, but it's very close to the correct radius we're looking for to match the key. I can finish grinding to suit the radius. The thickness is a bit too narrow to suit the key. I'll show you. But what we'll do is when the cutter is in the slot, we'll move the cutter up and down to cut the width of the key, the correct width. So I'm not fussed it's a bit narrow. What we're looking for is a nice, neat fit on the key. So this works to our advantage right at the moment. So I've just got to make sure we can get this cutter in without hitting our jigging setup, which is this area here. So I'll just put this cutter in here. It'll be hanging out about that far. I'm just going to nip it up by hand. Normally we tighten it up a lot tighter than that, but I'm not going to machine with it, and it will be coming out. Because I don't think I can see. I'm not going to be able to reach this, but I have to take measurements on how far away the machine has to be from the support, and I'm going to make an extension. So let's have a quick look. I can get the first key in, no problem at all. Plenty of clearance in here. That second key is what I'm concerned about. So let's have a look with that second key. Right, so have a look there. We're not going to make it. We're going to hit this clamp. That cutter has to be lined up with that keyway. So what I'll do is lift this up. And now line up my eye. I have to come across to about there. The cutter's got to come down to there. So I'll have to make an extension to connect that cutter to that chuck here. But I'm not going to use that chuck because it won't be big enough to carry an extension. So I'm going to put the bigger chuck in. Here's a bigger chuck.
But isn't that going to make the problem worse? I don't...
Yeah, that's what I'm concerned about. So I may have to come up even higher.
Okay.
But I don't have a choice. I've got to go in with the bigger chuck. So We'll get down to about there. Otherwise I could end up hitting the nut here. So let's have a measure. We're looking at approximately the cutter's going to need to protrude the bottom of the chuck by about 80 millimetres. I'll need to go inside the chuck about another 70 millimetres. So there's roughly 150 millimetres of extension I'm going to have to make up.
So the next little part of extending this cutter so that he can machine the second keyway in. So let's see, what are we doing now?
Okay, so I've cut the material off to length. So what I'll do now is machine a hole in this end. That's the cutting tool I want to put in. So I'm going to insert this into that bar. So for that to go into there, I need to make a hole into here. So I'll put it in this machine, the lathe, put it into here, slide that in. Got half a mil to come out, ballpark. That's it. Perfect. Fits in there. It's nice and tight. That's it. We're finished.
So I think Brad's ready to go with that cutter. Have you got everything together, or where are we at now?
Yep, yeah, I'll just put the cutter into the chuck.
Oh yeah.
So that's the extension piece we saw on the lathe with the whole board into the centre.
Oh yeah, yep.
And the cutter inserted on the end, and I've just put it into the chuck. We're about to put this into the machine and set it up. What I have to do now is I'll just touch the cutter on top of the crankshaft journal, and then that'll give me a datum point to know how far above centre height the cutter is, because that cutter has to be on centre height. When I turn the hand wheel, and I'm just going to rock that cutter backwards and forwards until I feel the bottom of the cutter touch the top of the shaft. Okay, now that's just grabbing the top of the shaft. It's just shaving the top of that shaft off. Okay. I'll move the job out of the way. Now I'm going to zero set off. See, it's just reading a coordinate. I want to set that coordinate to 0. So the top point here, top dimension there will be 0, and I'll work from there down. Now, we can get a measurement on the shaft. It's telling me it's 28.5 millimetres in diameter. So I have to halve that because I want the centre line of that shaft. So I'm going to drop that cut at 14.25 down to the middle of that shaft, the exact centre line in that shaft. So I've already set 0 to 5. That's it. Now I'm going to zero that off that cutter. I'm going to touch that cutter on the outside of that shaft and zero that off. And that'll give me a datum point or a 0 point to work my 5.5 millimetres in from. The cutting tool just touching that shaft, the edge of that shaft, the outer diameter. This is the Y movement. I'm going to go back into the control and I'm going to change that Y movement to 0. So that's a 0 point where I will start my plunge cut going in. I've got to go 5.5 mil deep. So I'll start at 0 and then I'll move in at 5.5, and I'll know I'm exactly 5.5 mil deep from the outside of that shaft. Mechanical, I'm 0. I just need to touch the cutter on the end of the shaft, and that will give me a starting point to come in and position those 2 keyways, because they're a set distance in from the end of the shaft. So I'll just do that now. Okay, that has got X. I've just felt that cutter just touch the end of that shaft. So what I'll do is zero that off on the control. X. Cancel. So that point there is 0. I want to bring the centre line of that cutter, the centre line of that spindle, in line with the end of that shaft. So I have to move it half that cutter diameter. So I'll measure that diameter, I'll halve it and move the machine that much. Okay, that is, it's 18.9, so we go 18.9 divided by 2, gives me 9.45. So I have to move that X 9.45 millimetres in that direction. .45. Now the centre line of that spindle, or the centre line of the cutter, I start all my dimensions from there. So I'm going to call that 0 and work my dimensions out from that 0 point. I'll put 0x. So those dimensions, that the centre of the first keyway is 11.75 millimetres in from the end of the shaft. So I've just got to go 11.75. Okay, we're there on that first one. Let's just double check. Looking pretty good. I'll just quickly show you my reference. This is what we call the machinery's handbook. That gives us all the dimensions for keys and that type of thing. You can look it up on the internet. I looked it up on the internet, got a little bit confused. It's just easier to look up the chart in the book, and that tells me everything that I'm looking for. Keyway depth and shaft, F, actually I'm one line out, that's better, is 214 to 219 thousandths of an inch in depth. So I'll just calculate that back into millimetres. 219. .56 millimetres. So I'll write that down. That's my maximum depth, 5.56. Minimum depth is 214 thousandths of an inch. Which is 5.43 millimetres. 5.43. That gives us a difference of 0.13 millimetres. That's our tolerance, 0.13, which is roughly 1.5 thicknesses of paper again. Before I start that cutter, I'm going to turn the coolant on, or we call it water. It's really coolant, it's just to turn the water on. And I want to direct those water nozzles onto the cutter before it starts turning. Have a look here. I don't know if you can see the back of this cutter. I want to direct the first nozzle onto the back of that cutter. So when that turns, the front of the cutter is going to be in the cut. When this rotates, it'll pull the water in with it. But I'm more after, as it comes out of the cut, any swarf, any chips of metal that on the cutter gets washed off before it starts to go back in again. So direct the other one back on to that shaft, and then that can keep pulling the water in with it as it goes around. So I'll turn the water off. I'm going to program the revs of that cutter to 500 revs. Right. So I have to go into a manual programming side of the control. So I get manual data input. To get that cutter to spin, but I get too far involved, I call up a code. It's called an MO3 code, which means spindle on. MO3, spindle on. So I'll put in MO3 first. MO3 input. So put MO3 up there. So the machine knows it has to turn the spindle on. I've got to tell it how fast to go. So that's an S speed. S designation. So we just call S. And I'll go 500, 500. Input. Out start button. That cutter's going to start turning. I'll just make sure it's clear. Here.
Before you start cutting it, I just want to have a quick look at that, a bit of a closer look at where the cutter's actually sitting. Now that we've got all the datum points, how's it lining up to the place where you're going to put the keyway? Looks lined up to me. He's got Jody admin approval. So that's good, I'm sure he's happy about that. This is where the cutter is sitting.
Bora. Here we go. Now, because I'm not sure how hard this material is, I might go in at that 500 mark. Let's go. Pull my position up relative, so I'm 1 millimetre away from the job. Remember, we zeroed it off before. I'm 1 millimetre away from the job. So I've moved the Y, that 1 millimetre, I'll hear it cutting. Get the water on there with the cutting. It's sounding a bit harder than I thought it was actually. Remember, we've got to go 5.5 deep. 5.56 maximum. I'm going to stop on 4 and have a look at that cutter. That sounds like it's a little bit clunky to me. Okay, so I'm going to get it out there. It's actually at that point. It's a bit harder than what I thought. Back those revs off a little bit, see if I can get through this cutter. Just drop that from 500 down to 300. I don't like the look of that cutting edge, but see what we can do. I'll double check my depth. Alright, so 5.5 will hit me right in the middle of that tolerance. I'll come in position on the readout. See where I'm going. It's got about 3.36. That's I don't know if it's broken a tooth off on that cutter. Just have a look. At the moment it's not sounding too badly. Too bad. Let's have a look, see what we've got there. What I'll do, I'm going to take the Z up out of the way so we can get in and have a look. Okay. I'll pull that cutter out and have a closer look. Yeah, it's not too bad. I'm happy with that. That, I don't know if you heard that little ting sound, that little click. I thought it might have been breaking a tooth, but it's actually flicked a bit of that hard weld, of the cold weld, out of the shaft. Have a quick look here. You see that? Chipped out the edge of the cold weld. Just chipped it out. There's nothing we can do about that. It's because the cutter rotates this way and then comes back out. So it didn't chip it on the way in naturally because the cold weld is supported by the body of the shaft. But as it comes back out, the cold weld's not supporting it. Obviously it's got under there and just flipped it out.
Hang on, Brad's disappeared into the machine.
Remember I said the thickness of that cutter is 2 millimeters. The thickness of the key, the Woodruff key, is 4.8 millimeters. So we just check here what they say for the width of the key seat, the slot in the shaft. They're saying D 606. They're saying D, keyway width in shaft, 187 to 189 thousandths of an inch. 187 to 189. Right, so never leave that decimal point unprotected. So we're 187, so we're 0.187 thousandths of an inch multiplied 25.4 is 4.75, so 4.75 millimeters, and the other one is 0.189, 4.8, so 4.8 millimeters. All right, and we're measuring 2 millimeters, so we're measuring 2 millimeters, 2.0. So let's take 2 mil off that. That'll give us 2.8 the difference, which is 1.4. So we've got to move up and down 1.4. I might move up and down 1.3. So I'm not sure how the cutter's going to cut, whether it's going to flex. I don't think it will. In theory it should flex left. So let's go 1.3 up and down to see what we get. I will just accurately measure the thickness of the key. As far as I'm concerned, verniers aren't really that accurate. I'd rather a micrometer. Depends what you're measuring and what sort of accuracy you're looking for. Right, so that's measuring 4.77 millimeters. So that's exactly what we've got here. 4.77 millimeters is the exact middle tolerance. The book's giving us plus or minus either side of that. And so the key's right in the middle, and the book is giving us the middle measurement plus or minus on the tolerance. So we're right. So we're going to aim for 4.77 millimeters. So if we go with that, 4.77, and we're now measuring 2 millimeters, 2.00, we take that away, we're left with 2.77, divided by 2 will equal, 2.77 divided 2 equals 1.38. So we're going to go 1.38 up and move Z 1.38, drop 1.38, and then that'll keep that key centre of the shaft. But I'm going to move at 1.3. Just lift it Z 1.3. Going back into that 5.5 mil leak on the wide. Now I'm going to drop the Z 1.3. I've gone up 1.3. I'll drop it 1.3. Move back in on the wide. There's a little bit more of a click on, like bang, and maybe the cold weld let go again. I don't know. Either way, I've kept going into my coordinates. Right, let's have a look. Okay, let's see how this key fits. Don't forget that curvature of the cutter matches the curvature of the key, or the radius. The radius of the cutter matches that radius on the key. So that goes into there. And that needs to be a tight fit, so it needs to be tapped in. So we're pretty well spot on for fit. So I won't go back in with the cutter again, otherwise it might make it a little bit loose or less tight than what it already is. So that's perfect. I'm happy with that. Can't get it back out. Okay, done. Now I'll have to move to that next keyway. Remember I said we picked up off the end of the shaft? I know the centre line of this keyway, how far it is from the end of the shaft, and I know the centre line of that keyway, how far it is from the end of the shaft, which is X movement. If I go back to my notes, that second keyway is 37.3 millimetres in from the end of the shaft. And we're talking about centre line here, not the edge of the key, but the centre line of the key is 37.3 millimetres in from the end. So we just pitched that in on the X. So X is 37.3. 37.3, I'll double check that dimension. 37.3, so centre line of that cutter should be in centre line of the keyway. Keyway slot. I bring this down to our Z height, which is 0. Okay, now we'll just start machining again. We have got enough clearance here. Beautiful. So that's a broken cutter. Just smashed it. And I don't know why, there might be something hard in there because the sound did change. I thought I'd hit the crankshaft, but I hadn't. There's definitely either hit something in there or part of that cold weld has let go. And that could have come around and got caught in the cutter and jammed in there. That's possible. So I'm not sure why that broke, but definitely didn't hit the crankshaft.
After the cutter broke, cutting that second keyway in, he made another cutter and put it back in the machine. And so I thought he might be able to just quickly overview that before it goes out to the customer and goes off and does its job. So Brad, would you be able to do an overview for us?
Yesterday afternoon, this was the first keyway I cut into the crankshaft. The very first keyway in from the end of the shaft. Had no problem cutting that, not a problem at all. I moved to the next one, and when I was about 2 millimetres into the shaft with the cutter, it just broke, it just snapped. And it didn't give me any warning. Normally you get a little bit of warning. It didn't give me any warning, which made me think there's something wrong in the shaft. There might have been some hard spot or inclusion in there. So made up another cutter. It's this one here. Rough and ready, but it did the job. And that's just gone in like that. Turns around and we just plunge it into the shaft like that. And it just scallops that out. This cutter's double the thickness of the other one, because the other one was an old one that we had laying around. So we quickly made up another one, made it thick enough to give it a little bit of a bit more strength, and we had no trouble. We did find that we did pick some inclusions in here, like hard spots, or I don't know what it was in there, but there was something in there that I think jammed the other cutter and caused it to snap instantly. So we've cleaned all that out, put this cutter in and remachined this to size, because this cutter is a little bit thinner across here than the width of the key. So we go in, we cut it, we take a measurement, then we move up and move down to get the correct width for the key. So this one went through no problem at all. Stayed back last night to get it done. It's an urgent job. We didn't get all the filming done on the second Keyway because we were back late. This is ready to go. Customer should be here in a few minutes to pick it up. So, happy with the keys. There's the keys. They're a really tight fit, or very neat fit into the shaft, which is what they have to be. As I say, I'm disappointed with the cold welding, the way it's actually let go there. It's chipped away a little bit. There's nothing we can do. We've never machined cold welding before, so I'm not really sure how it behaves when it machines. We've had no problem in the other areas of the Keyway. It's just where the cutter rotated and come out seems to have lifted the cold welding from the surface, the original surface of that crankshaft. But either way, the keys are an excellent fit in the crankshaft. They won't have any problem there. There's two pulleys that get pushed on there. So you won't even see that. Not that it matters, but it's not going to affect the performance or the holding power of those pulleys when they get pushed on. So that's it. So it's all ready to go. The customer should be here any minute. So that's it.
Well, thanks, Brad.
Material off. Right, start again. So I've cut.
How is it lining up with that key? Or that place where we... How's it lining up? I've asked Dad... I've asked Brad if he can quickly give us an overview.
0.13, which is roughly 1.5 thicknesses of paper. We work in those measurements paper and that because we recycle here, and then so we get all the used measurements that come in, and we can buy the measurements are a lot cheaper, the recycled ones. You do have to watch the bad ones and take outside and tolerance or wreck the job.
Yeah, I want the bad sheets of paper.
If you buy good quality,
quality printer paper,
recycled, yeah. And then once we're finished with all these measurements, they go back in and get recycled.
Okay.
So that's why we're talking paper measurements.
All right, Dad. So, Brad's... Oh, yeah. Oh, where'd you get out? Oh.
No.
Oh.
You think I took the old crankshaft there?
That's not... Oh, no. So, this is different, but the same. Right? So, Brad has found where the cutter is sitting, and that's...
Yes, that's correct.
Which one's that? Is that Y?
That's Z.
Oh, okay.
Z.
Hang on, that one's Z. Oh, no, hang on. Hang on, sorry, no. So then he did it this way. So now we know where this cutter sits here. And he knows where this is because he's done this dimension. And so now he's going to know how far he comes in. Right, and that's...
It's Y.
That's Y. Okay, our Keyway is going to be positioned this way. And so this is X. So that's the last one we need to sort out. And then we've got our depth, our length, our depth, and our width. I don't know if that cleared anything up or not.
You can do it.